So today we're going to be learning about solving systems by using a method called substitution. Remember that a couple weeks ago we had solved by graphing, and so now just a different way is solving by substitution, where all we're going to do is just plug one thing into one equation into the other equation. So just in the same way that if I said that x was equal to 3, I could substitute it into the equation. All I would do is, since I said x is equal to 3, I would replace the x with a 3. And so I would get y is equal to 4 times 3 plus 5. And so I would know that y is equal to 12 plus 5, which gives me 17. So in the same way, what I can do is I can actually take an equation like this, and I can get one of the variables, so I can get y is equal to or x is equal to, and then plug it into the other equation. So with the problem here, I'm going to be kind of underlining on the left-hand side of your notes and going through the example on the right-hand side. So the very first thing that I want to do, the first step that we have here, underline that first step, is I want to solve one of the equations for one of the variables. We always want to do the one that is easiest. And the one that's going to be easiest is going to be the one that has no number in front. So there's no number in front of it, there's no coefficient. The invisible number that's in front of the variable that is the easiest is always going to be a positive 1. So with this first problem, what we should be able to see is that on the top equation, my x has a 2 in front of it, my y has a 2 in front of it. The bottom one, I've got a negative 2y in front of there, and the x is the one that doesn't have a variable number in front of it. And so I want to get the bottom one, I want to get x by itself. And so to get x by itself, I'm going to add the 2y over to the other side. And so I get x is equal to 2 plus 2y. Once I have one of the variables by itself, what I want to do is I want to substitute it or plug it in to the other equation. So what I want to do here is I want to take this, I'm going to put parentheses around the right-hand side, and I want to plug it into the other equation. So since I got the bottom equation, x by itself, I'm going to plug it into the top equation. And so again, since I got x by itself, I'm going to plug it into x of the other equation. So what I'm basically going to do is take what I highlighted in blue and plug it into for x. So I'm going to grab this and replace the x. So the x will disappear, and in its place will be the parentheses. So what I end up with is, so this was my first step. My second step is I will have 2 parentheses 2 plus 2y plus 2y is equal to 10. Then I can distribute, get 4 plus 4y plus 2y is equal to 10. Combine my like terms to get 4 plus 6y is equal to 10. Subtract the 4. From there, it's just solving an equation like we've done before. So 6y is equal to 6. And then divide both sides by 6. So I get y is equal to 1. And there's one of my answers. Remember that just like when we graph these, my final answer, my solution needs to be an ordered pair. So I need an x and a y. So once I've solved for one variable, the third step is that I want to take the number that I just got there and plug it into the very first step that I had. So with my third step, what I want to do is I want to grab this, so I have y is equal to 1, and I want to plug it into the original equation up here, my very first step. So I'm going to grab this and plug it in right there. You can plug it in anywhere you want, either of the original equations or that first step. The first step will always be the easiest. So I end up with x is equal to 2 plus 2 times my y, which is 1. And so when I do that, 2 times 1 is 2, and then 2 plus 2 gives me 4. So I've got x is equal to 4, and I've got y is equal to 1. So remember, I always want to show this as an ordered pair. So it's going to be the ordered pair 4, 1. Once I do that, what I want to do is I do want to double check my answers to make sure that they work in both of the original equations. So I can go back up here. Again, my ordered pair was 4, 1. And so I can go 2 times 4 plus 2 times 1 is equal to 10. 2 times 4 gives me 8. 2 times 1 gives me 2. 8 plus 2 gives me 10, so the first one works out. Next one I can get is 4 minus 2 times 1 is equal to 2. So 4 minus 2 gives me 2. That also works out. So I know that my ordered pair solution of 4, 1 works with this equation. With the problem on the bottom, again, first thing that I want to do is I want to solve one of the equations for one of the variables. For this one I could do either the top or the bottom because there's an invisible 1, there's not a number in front of the y, and so it doesn't really matter. So I think I'm going to go ahead and do it for the top. So I'm going to add the x over to the other side. So I get y is equal to 1 plus x. Again, I'm going to put that in parentheses. That's my first step. And then I want to go ahead and plug in, since I got y by itself, I want to plug this in for y of the other equation. So I'm going to grab this, and I'm going to plug it into the other equation for y. Remember that whatever variable I get by itself in my first step is going to be the variable that I'm plugging into the other equation. So for my second step, I've got 2x plus parentheses 1 plus x is equal to negative 2. There's nothing to distribute here, be a little careful. I've got just a plus sign in front of my parentheses, and so I don't have to distribute anything. If I would distribute anything, it would be a positive 1. And so from here I can just combine my like terms, get 3x plus 1 is equal to negative 2. Subtract the 1 to get 3x is equal to negative 3, and divide both sides by 3 to get x is equal to negative 1. Once I get one of the answers, again, I'm going to grab this and plug it into the first step. So my third step would be to find my other variable. So I get y is equal to 1 plus negative 1. So I get y is equal to 0. And so my ordered pair solution is negative 1, 0. Again, I do want to double check these. So I want to plug the ordered pair negative 1, 0 into my original equation. So when I plug it into the top, I will get negative 1 plus 0 is equal to 1. A negative 1 is the same thing as positive 1, so 1 plus 0 is equal to 1. That's true. And the second one, 2 times negative 1 plus 0 is equal to negative 2. 2 times negative 1 gives me negative 2. Negative 2 plus 0 is negative 2. Flip over to the back. On the back, again, same thing with the first equation. I want to get, I could get either x on the top equation or y of the bottom equation by itself. I think I'm going to get x of the top equation by itself. And so I'm going to subtract the 2y over to the other side to get x is equal to 14 minus 2y. Once I'm there, I want to plug this in. I'm going to plug it in for x. And so I'm going to grab this, and I'm going to plug it in for x. Get negative 3 parentheses 14 minus 2y. Oopsie. Plus y is equal to negative 14. I can distribute. Let's see, 42 I think, negative 42. Yeah, so I get negative 42 plus 6y plus y is equal to negative 14. Combine my y's together to get negative 42 plus 7y is equal to negative 14. Then I can add the 42 to the other side to get 7y is equal to 28. Divide both sides by 7, so y is equal to 4. Again, I want to take this and plug it in. And so I get x is equal to 14 minus 2 times 4. 14 minus 8 gives me 6. And so my ordered pair solution is the ordered pair 6, 4. So again, double check to make sure that I'm right. When I plug it into each of the original equations, let's see, 6, 4. So I go 6 plus 2 times 4 is equal to 14. It checks out. 6 plus 8 is 14. And then negative 3 times 6 plus 4 is equal to negative 14. That gives me negative 18 plus 4 gives me negative 14. That works out as well. So both of those solutions work. Then with the last one, I want to get my y by itself at the bottom one. And so I'm going to add the 2x over to the other side. Get y is equal to negative 3 plus 2x. Put parentheses around it. Again, I got y by itself, so I'm going to plug it into y of the other equation. So I'm going to end up with 3 parentheses, negative 3 plus 2x plus 4x is equal to 14. I can distribute, get negative 9 plus 6x plus 4x is equal to 14. 10x when I combine these guys together is equal to 14. 10x is equal to 23. And so divide both sides by 10. I added the 9 to the other side to get that 23. So I end up with x is equal to 2.3. Once I'm there, again, I'm going to grab this and plug it into one of the originals, or the first step that I had there. And so I get y is equal to negative 3 plus 2 times 2.3. So when I do that, I get, let's see, 4.6, so I think I get 1.6. Yep, 1.6. So my ordered pair solution is 2.3, 1.6. So it's okay to get fractions or decimals. And then I can plug it back into the original. Just be careful, make sure that my y is going where my y goes. So I go 3 parentheses 1.6 plus 4x, 4 times my x, which is 2.3, is equal to 14. So 3 times 1.6 plus 4 times 2.3 gives me 14. That checks out. And then the second one, 2 times 2.3 plus 1.6 is equal to negative 3. Whoops, negative. That's a negative 2, my fault. Thought I made a mistake. 6. There we go. And that checks out as well. And so that's my ordered pair solution. Double check to make sure that it's right.